All right. That was good. It's actually Zerve. No, it's not. I'm kidding. It's Zerv. You had it right. All right, awesome. Well, hi everybody. I think we have the smallest room, but the highest IQ to cubic centimeter ratio of any room in the conference at this point. So that's good news. I'm Greg Michaelson. I came from a company called Data Robot. Anybody familiar with Data Robot at all? Yeah. I joined in 2015. It was a different world back in 2015. People were still sort of moving to the cloud, and everybody was convinced that the citizen data scientist would be sort of taking over. Yeah. I've never actually seen a citizen data scientist except in grainy photos in the woods, which is supposed to be a joke. Uh, but I joined a company called Zerv, and we are looking at the data science development experience. So I'm going to do something profoundly unwise in this talk, and that is talk about how data scientists do things, which there's a pretty wide spectrum of data scientists. I'm somewhere in the middle of that spectrum. You've got guys on one end that go, well, I do everything in Vim because that's how I code. That's how intense I am as an engineer. And then you've got other people that are like, oh, I use Data Robot and I never touch my keyboard. I always use my mouse to do my data science. So there's like a spectrum of people. So when I generalize, just think the worst of me, but don't say it out loud, and then we'll get along. So, um, Jupyter notebooks. How many of you have ever used a Jupyter notebook before? Yes, my people. I dreamed that I would ask that question and no hands would go up, and then I'd be like, well, funny enough, let's talk about Jupyter notebooks. So I'm going to give you 4 reasons why I think there are significant problems with Jupyter notebooks, and maybe we can think a little bit about how we might fix those. It's a bit self-serving because Zerv is designed to fix all of those problems, but I'm not going to talk about Zerv at all. Well, maybe a little, but I'm not. It's not a sales pitch. So if you want to find out about Zerv, just come to our booth, and we will happily deliver the sales pitch. Even though we don't actually have a product to sell yet, we don't launch until May. So, okay, so. That is Fernando Perez, the guy who invented Jupyter notebooks back 20 years ago or so at Berkeley. They were called iPython notebooks back then, and certainly there have been lots of contributors over the years to them. But the quote is fascinating. He said, I thought maybe I could build a small tool that would make that process of running a bit of code, maybe plotting, visualizing some data, continuing to write code, a bit easier. And so he sort of betrays the reason that he developed these notebooks in the first place, and that is to be a scratchpad, a place to go and kind of explore and do interesting things. But that's also one of the big downfalls of notebooks. When you ask a data scientist what tool stack do you use, most of the time they'll say, well, I like notebooks. Notebooks are really interesting. They're great for exploratory analysis, but if I'm doing anything really serious, then I go to Spider or VS Code or PyCharm or some scripting environment where I can, write something that will actually not fall over as soon as something goes wrong with it. So a little illustration. Here's a screenshot of a Jupyter notebook. I set a variable a equal to 1, and then I add 1 to it, and I get 8. Who knows my devious trick? How did I do it? I ran it a bunch of times. Yeah, that's the problem with Jupyter notebooks one of the main problems is that they just sort of run code sequentially behind the scenes, but you can actually run the cells in any order you want. So if you find somebody's notebook from grad school or something, there'll be a comment that says, run this cell after you run the one 8 cells later. Otherwise, you'll get weird results, right? So these notebooks were designed to operate as scratchpads, and that's why all of them have this restart the kernel button, which I was thinking about this last night, and I was trying to imagine the circumstances that gave rise to that button. Because surely when Fernando Perez started building Jupyter notebooks, there was no restart kernel button on the toolbar. Like, it can't possibly have been his intention to build that button. What happened was version 1.0 came out, and his notebook got in a bad state, and he said, oh, he doesn't want to have to kill terminal and then restart the notebook. So he needed a restart kernel button. That's how that button came about. And so if you use any notebook environment anywhere, whether it's Jupyter or Databricks or Hex or Google Colab or any notebook environment out there, they all have this button. Even though if you set out today to design a notebook environment, there's no way that you would create that button. It's a sign of an architectural problem, that notebooks were designed to be scratchpad type environments for academics and not serious tools used to build machine learning in business. Make sense? Okay, cool. Number 2, the underlying architecture of notebooks is really quite obsolete. This is kind of how people, well, here I go generalizing, how data scientists do data science. You download your data locally, you open it up in a Jupyter notebook. Hopefully you don't win the lottery so that all of your work goes away, or hopefully you don't lose power and you lose everything, and so on. And then you have email collaboration, where you're like, I mean, you can't manage a Jupyter notebook in GitHub, right? Because it just doesn't work. So you end up doing things like slacking files to each other, like notebook files to each other, and then people go and have to change all the paths. You know, it's like, it's crazy because it's an obsolete architecture. I was working with Health and Human Services, part of the U.S. government during COVID, and we had a project where we were trying to help with the vaccine trials, the COVID vaccine trials. I didn't know this, but it turns out that when you run a vaccine trial, the secret to a successful vaccine trial is getting enough people in there that actually get sick. Because what they do, it's a double-blind study, and once you have enough sick people, you can measure a statistically significant difference between the people who got the vaccine and the people who got the placebo. Well, in the US, people who aren't white don't participate in clinical trials because in the US history, there's a lot of sort of unsavory things that happened in medical experimentation and stuff with minority groups. So it's sort of out of the culture of minority groups to participate in those kinds of trials. Well, it also happens that minority groups in the US for COVID were being infected at a much higher rate, which means that if you're conducting a vaccine trial, the more diverse group of people you can involve in that study, the more quickly the study will complete and the faster your vaccine gets implemented, right? Or gets approved by the FDA. So literally, the fewer black people that you enroll in your study, the more people die of COVID because your vaccine didn't get released in time to save them. And at that point, there were thousands of people dying every day to COVID. So it was really important to get people involved. So we're working like 18, 20 hours a day trying to build a simulation to talk about, okay, you should target these neighborhoods and you should advertise here, and these are the things you can do, and we think it'll shorten your trial by 2 weeks or 3 weeks or 4 weeks or whatever it might be. We were working in notebooks, as you do. And we were doing these things, emailing notebook files back and forth and slacking files, and who's got the latest version of the notebook, and okay, we're going to sleep in America and the German team is waking up, and everybody send them the latest notebooks. It was insane. It was completely insane. So what do you need? Skip that slide for a second. You need a cloud-based notebook. That's what you need. And so there's actually tons of these that have come around. I think Hex is the latest one. They've raised, I think, $70 million or something in funds. You know, they're going really well. This super slick interface. Hex is collaborative. Google Colab is free-ish. Databricks is horrifying. Datalore, there's lots and lots of, ignore the Zerv column, the Zerv slides, so we of course have to have a check mark in every box. But this is sort of table stakes for the type of notebook that is getting created today. All of these different features that sort of exist over here. But what you'll notice is that the scratchpad nature of notebooks, if you put them online and let lots of people log into the same notebook at the same time, so that lots of people can run different cells inside the notebook all at the same time, it actually makes the problem significantly worse than if you were just working locally and emailing files back and forth. Because a collaborative notebook in the cloud that's still based on that scratchpad architecture gets in a bad state significantly more often than if you were working separately and communicating like they did back in 1990, right? So this, actually, let me jump back here. Another example of the obsolete architecture of these things is that they are all single-threaded. Every data science development environment that I've worked in, from SAS to RStudio to Jupyter, once you start it thinking, you either need to open up another tab or pull out your laptop or your other laptop and start working on that. My first job was in a bank in the U.S. and we were doing, this is like years and years ago, and we were running SAS. And it turns out if you open 2 SAS sessions on the same computer, that weird stuff starts to happen. They interact in really unexpected ways, so you have non-repeatable bugs and such. So I actually had 2 towers that I was running, 2 computers with 2 monitors and 2 keyboards and 2 mice. And my biggest problem was accidentally switching the mice. So I'd grab a mouse and where is my mouse? That sort of thing. Everything still works that way, right? Like Jupyter is still single-threaded. When I run in those environments, I've got like 8 tabs open across the top, and it's different notebooks, and you can tell by the little icon in the tab whether or not it's still thinking. You know what I mean? So you're like, oh, that one's done, and I'll work there. It's crazy, right? Well, why can't we have an environment where I can run multiple things all at the same time? That's another example of the obsolete architecture of notebooks. Okay, third, copy and pasting everywhere, right? What is the shortcut key for cut, copy, and paste? Does anybody not know off the top of their heads the shortcut key for cut, copy, and paste? It's Control X. Exactly. Everyone knows. Why do we know? Because you do it 1,000 times a day, right? How about this one? Anybody work on a Mac? Shortcut key for a screenshot? Yeah, I don't even know the keys. It's just that. That's how you do it. Right? Command Shift 3 and 4? Yeah, everybody knows. Why? Because you take these things all the time, right? So you finish all your work. You've got your beautiful Jupyter notebook. You got your graphics all laid out. They're perfect just like you like them. And then you open up PowerPoint and you Command Shift 3 and you drag the thing and you paste it into the PowerPoint slide. And everybody's happy until the data changes or somebody asks a question, and then you have to remake every slide and change every number and redo all the screenshots and everything. We know these shortcut keys because the whole ecosystem is built around copying and pasting things into other environments, right? PowerPoint. And for production, I mean, most data scientists are not machine learning engineers, right? Who are like used to building like production type pipelines. And so what'll happen is the engineers end up copy and pasting sections out of notebooks into some production environment like Airflow or whatever, so that the code will actually run and be usable in some kind of a real environment. So whether you're the data scientist trying to show your results, or whether you're the software engineer, the poor software engineer who has to clean up after hacks like me that are not good coders but still write code to do data science, you end up doing a ton of copy and pasting, and so you memorize all the shortcut keys. Okay, number 4, automation is built for the wrong people. So I mentioned at the top that I came from Data Robot. I joined there in 2015. Like I said, the great hope back then was the citizen data scientist, who we were going to empower to build machine learning models by abstracting away all the technical bits. And so all they would have to do is drag in a data file, and the tools would magically transform the data, standardize it, take care of all the missing values, encode all your categoricals, do your embeddings for any text variables, automatically try all the different kinds of models, and then give you a model that, oh, by the way, it's also a deployment, and so you can do everything with all you have to do is drag in the data set, and you're done. Right? The cool thing is that the tech can actually do it. Like the AutoML software is real good. The problem is the business analysts can't comprehend it. So I was at Data Robot. We actually hired 100 former McKinsey people and we assigned them the task of putting together what we called use case workshops to go around from customer to customer to try and help them figure out reasons to use our software at DataRobot. Is that crazy or what? It's like AutoML somehow became a solution in search of a problem. And that's a fact. But in reality, well, what happened was that DataRobot sort of gave rise to all of these GUI-based machine learning tools, like your Alteryx and your data IQs and your, these kinds of tools that are like mouse tools. It's the war between the machines, and those are kind of coming up. And what you see with companies like that is that their customer net retention tends to be really poor, because it's easy to sell AI tools, but it's hard to get non-data scientists to adopt those tools if they're the actual users, because they don't really know what they're for. So the keyboard is winning, in my opinion, because the only people who are actually getting value out of machine learning are the people who are able to code and use it and who know what it is. But the way things like AutoML work today, here's the workflow. It's pretty great. You take data and you put it into some sort of an automation machine, and then you cross your fingers and hope that the automation is flexible enough for the problem that you want to solve, and that there isn't anything unusual or out of pattern in your particular use case to make it where it doesn't work. And then you find out that that, of course, isn't true, and then you just find somebody to do it by hand. That's how AutoML works today, for the most part. Here's how it should work. You take your data, you put it into some sort of automation machine, and that does some automation and builds some stuff, but then it gives you the code for that stuff that it built so that you can take it and adapt it to whatever the specifics of your particular problem should be. Unfortunately, there are no actual tools that really seem to do that very well out there today. And then everybody's happy. So this is a slide about Zerv. We won't talk about that. But the idea here is that, in fact, oh, that's the last slide. Okay. So the idea here is that there are an awful lot of options out there when it comes to where you develop your machine learning algorithms, and you have lots of choices when it comes to what tools to use. Some of them are mouse-based, some of them are keyboard-based, some are scripting type environments, some are much lower level, some are more exploratory. But certainly I think that the exploratory tools are necessary to do data science, because you have to have that sort of iterative kind of process where you're able to explore, see what the data looks like, and so on. And that's not straightforward, or at least it's not convenient in most scripting and software engineering type tools. So I think a unique tool set needs to be developed for data scientists that is code-based, but also really interactive, that also is stable enough to actually be useful in a production type environment. And I don't think any of those tools, except Zerv, have been built yet. So it's actually really interesting. There's been a huge amount of innovation on both sides, mouse-based and keyboard-based, but they're all sort of missing the boat in terms of hitting all three of those checkboxes: deployable, interactive, and also complete. So that's all I had. We have 10 minutes or so left for questions. And you can completely disagree with me. Those are the most interesting type of questions. So.
Yeah, thank you, Greg. At least for me, it was very familiar having these several Jupyter tabs open. Cannot wait to work with this solution. Are there any questions from the room? Yeah, we'll come to you with the microphone so the people online can also hear it.
Thanks for the talk. Yeah, very familiar as well, lots of the issues. Do you think there's a space for individual tools which solve part of the problem, or do you think it should be an all-encompassing complete solution? Maybe you've already said you think it should be complete, but maybe talk about the trade-offs there.
I think that what you see with most vendors is that there's a deep desire amongst vendors to keep you in their tool, in their platform. And so you end up kind of stuck unless the platform is perfect, and none of them are, right? So then you have sort of, I think most people, when you ask them what tech stack they use in data science anyway, they'll say things like, well, some of everything, right? Like we use some notebooks, and we've got, and the more sophisticated they are, the more they've moved toward a system that is relatively inflexible but really good at the specific stuff that they need to do. So I think what you need, I think the key to having a winning toolkit in the data science space is one that will allow you to do what you need to do inside it, or to pull what you need out of it and move into some other tool. So certainly that's one of our values in what we're building, is that wherever you are in the process, you can suck out all of your stuff from Zerv and put it into whatever else you need in order to get what you're doing done. So I think the flexibility is the most important thing. But everybody's going to try to build that end-to-end ecosystem, which I think is probably a bad idea. Anyway, that's my opinion.
Yeah, other question?
So why not teach people to code better?
It's a good question. Why aren't data scientists better coders, I guess is the question. Yeah, I mean, right? They should be. I should be. We all should be better coders. But you sort of work with what you have, I guess. Certainly in what we've seen is that organizations kind of have who they have in terms of resources. And one option would certainly be to fire those guys and hire machine learning engineers, which would be great for machine learning engineers because salaries would go way up, right? Because how many of them are there really? But on the other hand, I think there's a balance, right? You need the guys that can open Notepad and from scratch, pull in data from, I don't know, some obscure Hive, say some crazy Hadoop system, and just using a text editor, and then code up the algorithm for gradient boosting from scratch, and also do that and save that model out and then put it in some production. Yeah, maybe you need that. But I think there are also a type of data scientists that are more sort of exploratory, that focus more like on the art side and maybe more on the science side than on the coding side. And I think there's always going to be sort of a give and take between those two guys or gals. And I think they both sort of bring some fun to the party. I'll give you an example. There's a guy named Sergey Jurgensen who was a #1 Kaggler. You guys know what Kaggle is? Yeah, okay, right, I forgot where I am. Nobody even knows what Kaggle is. But he was #1 for 2 or 3 years, and there was this one project where it was using telescope data. This is one of the competitions he won to classify star types or something. It was some obscure astronomy thing. And of course, he's not an astronomer. He doesn't know anything about astronomy. But in looking at the data, he happened to notice this one little pattern in the data set that gave him an edge over everybody else. So today, Kaggle is only about finding target leakage at this point. So it's not fun anymore. It's been broken. But back then, he found this one really interesting feature that had nothing to do with coding and everything to do with, I just got in a notebook and I just started playing until I found something that was really interesting. Sergey can't do the Airflow stuff. Like he can't build a machine learning pipeline, but most of those guys can't find what he found, right? So I think it's about different skill sets and kind of like, diversity and all that jazz. I don't know. That's a rambling answer. But we should all be better coders. It's my way of saying I don't want to be a better coder. Shut up.
Anyone else who has a question? Yeah.
Do you know a guy named Thomas Whitehead? You look exactly like him. It's weird.
Oh, never heard of him.
Okay, right on.
Okay. So why don't you like Databricks? Because I heard you saying something about
Yeah,
Databricks.
the last time I said that, somebody asked me the same question. And I may be out of date on Databricks. I haven't looked at Databricks in like a few years. But it's my experience that it's super hard to get started with those guys. That it takes the learning curve for me was super steep and very annoying. And they don't have a free product. So I think that any good tool in the space needs a valuable, always free product. And so anytime I see like a 14-day trial, I really, really don't like that. And then also, it may not be the case anymore, but Databricks is kind of an always on kind of thing. So I think the compute cost on Databricks is pretty high as well. So I don't know, it could be a good tool. I don't have deep experience in Databricks. I mostly just like to be controversial. So
Thanks.
I mean, they're worth, what are they worth now? 40 billion or something? You know, like, look at me, Databricks sucks.
So thanks for the talk. At some point you mentioned iPython / Jupyter notebooks. Those started as an open source project. And the fact that today we have so many vendors who came up with their own solution, does it mean that at some point we missed an opportunity in the open source world to draw like specs and a standard that people could have followed instead of like having everyone build their own sauce?
I actually love that question. This is an example of why open source is hard, I think. I don't know how with a tool or in an open source kind of development environment, you make such a deep architectural change to like get rid of the restart kernel button. Like, I don't think that's possible. Like, even if you had 1,000 people who wanted to do that, I'm not sure how you would make that happen in an open source project where you've got lots and lots of contributors. Maybe that could totally happen. It's possible. For Zerv, we decided not to be open source, but to have a free product. Yeah, I like the open source community, but a lot of times the people that are organizing these open source tooling, they're trying to actually build a company. So if you look at companies like, anybody use Ray? Ray's like distributed compute kind of thing. Ray is built and maintained by a company called Anyscale, and they have a commercial product, which is, as far as I can tell, exactly the same as the open source product. So this kind of open source, Databricks did really well with open source, right? Spark is open source. Databricks built a differentiated product that's significantly different and better than the open source product. A lot of companies that start out as an open source program or project don't. And so there's not much differentiation and they end up struggling. But at the same time, they do advance the open source community. So I don't know if I answered your question. I just rambled for 5 minutes.
Yes, maybe just a quick follow-up, maybe to narrow things down.
Yeah.
It's not really more about the product itself, but really more about the specifications. You know, nowadays you want to design a REST API or a GraphQL API, you need to follow specifications. Same thing goes with, I don't know, designing a database, you have to abide by specific rules. As the designer of a new product in the notebook space, do you feel like it would have been easier to start from like a set of like well-known specifications taken from like the lessons of many previous iterations, instead of like starting not really from scratch but almost like having like some kind of baseline, a reference?
So I can speak for Zerv. I mean, we certainly came in with an opinion about what we think was needed. We definitely have views about that, and we really are building on kind of what Jupyter started in a lot of ways, even though we didn't actually use any of their code, any of the open source projects when we built what we built. Yeah, I don't know. I guess it depends on the project. Any other questions I can not answer?
Yeah, thank you for your talk. It's very interesting, and I can relate because I also work in clinical trials and I work with SAS.
Nice. My condolences. You know what SAS stands for?
I'm currently Python.
Do you know what SAS stands for?
Yeah, no, actually, no.
Semicolon, always semicolon.
All right, that's fine. I just was wondering, how do you propose to, what's your vision to address the screenshot issue? So, I mean, after listening to the talk about like data visualization, storytelling, anyway, the decision makers do not want your notebook at the end. They want PowerPoint or something like that. So what's your vision on that?
What we do in Zerv is we automate the creation of the slides. So you can dump slides directly out of Zerv into PowerPoint. So What's that? he audibly groaned. He was like, "Oh, why?" Yeah. No. Like it or not, PowerPoint is the language of business, and there are an awful lot of app companies that have come along that shoot, what is that one that? Oh, I'm out of time. We have a little bit of time. Oh, God. There are an awful lot of companies out there that are like, you can build apps with us really fast. None of them, I can't think of the names of any of them off the top of my head, but there's tons of mountains of them. And nobody's using them. No CEO or business leader is going to log into an app to look at stuff, right? They're good. Why don't you integrate into PowerPoint? Yeah, why don't you? Easier said than done. You certainly could do it. It's not hard to push into PowerPoint. It's hard to push out of PowerPoint is the problem. So maybe a Google Slides integration would be a little bit easier. But and there's a company that I saw called Equals, I think, and they're trying to build a Google Slides competitor, which might be worth a Google. I haven't looked into them at all, but the approach that we're taking is to make it really easy to automate the creation of slides so that you never have to actually go in and copy and paste and that sort of thing. Download as PowerPoint, exactly. Yeah, that's what the button says, actually. So maybe we're part of the problem. Well, I'm questioning everything now.
So more questions. Thanks. It was very relatable. More questions on the features or how you're thinking about stuff about the GitHub or Slack email sharing or not. How are you thinking about that? Because we are keeping our notebooks in GitHub and we are actually reviewing the awful, JSONs. Yeah. Yeah. So we suffer that, and I think I saw some kind of GitHub plugin out there, but it's a paid one. Extremely expensive for what it does. That seems simple. Maybe it's not.
Yeah. I don't know exactly how Jupyter notebooks work under the hood, but every time I've ever tried to put one in GitHub, they always change. Like there's some metadata or something in there. Maybe it's a timestamp or something. What's that? Okay, well, something like, that's probably it. It's impossible, right? So what we do in Zurv is we integrate with GitHub just the code and the metadata separately. So, I'm happy to talk to you about that later. But
right. Cool.
Yeah. We also do version history inside the app. So we're trying to do like a Google Docs kind of version history type thing inside the app. But I recognize that's not. Some people want to have pull requests and that sort of thing. So, anyway.
Well, thank you all for the questions. Please give Greg a round of applause.